Now we'll get a little more specific and we'll talk about the HCF and LCM of exactly two numbers, not three, not more than three, exactly two numbers, because there are certain results that we can derive which correlate both the numbers with the HCF and the LCM. Now I'm going to take an example here. Let's take 24 and 90, right? So I got these two numbers and let me use the prime factorization method to figure both the HCF and LCM of both these numbers. So 24 is 8 times 3, 8 is 2 cube times 3. So this is prime factorized 24, right? Now 90 is 10 into 9, 10 is 2 times 5, so 2 into 9, which is 3 squared, into 5, right? So this is prime factorization of 90. Now the HCF, for HCF I'll write only those factors which are common across both of these numbers, so 2 and 3. And for LCM, I'm going to write all the numbers, all the prime factors which are a part of either of these numbers, right? Now for HCF, you would recall what I need to do is just pick out the lowest of the powers. So the lowest power of 2 across both these numbers is 1. So this becomes the HCF. This goes to HCF. Then for 3, the lowest power is again 1, which comes from 24, and I get my HCF 6. For LCM, now I've got to just pick the highest of these powers, right? So the highest power here is 3, the highest power here is 2, and the highest power here is 1, right? So my LCM is 2 cube, 8 5 the 40, and 4 9 the 36, so 360. That's my LCM. Now it's very interesting to see. Now let me just use another color to highlight what is interesting. Now I've used just these two numbers and found their HCF and LCM, right? Now you notice that 2 to the power 1 and 3 to the power 1 come directly from here and here, right? And I'll use another color now. 2 cube comes from here, 3 square comes from here, and 5 to the power 1 comes from here, right? So the point I'm trying to make here now is that actually all the prime factors inside of this first number and the second number are actually just simply redistributed into HCF and LCM. So there's nothing inside of HCF and LCM which has been left out, and there's nothing which has additionally come in, right? So therefore I'll just rewrite 24 into 90 here. So 24 into 90 is 2 cube into 3 to the power 1, right? And 90 is 2 into 3 square into 5. And HCF of 24 and 90 and LCM of 24 and 90, which is 6 times 360, is nothing but 2 to the power 1 into 3 to the power 1 multiplied by 2 cube into 3 square into 5, right? So you notice you notice that all of these factors, one way or the other, have redistributed themselves, right? All of these factors have redistributed themselves, which brings me to the conclusion that 24 multiplied by 90 is exactly equal to their HCF multiplied by their LCM, right? So if I were to generalize this result, if I have two numbers A and B, then their product is going to be equal to their HCF, which I'm going to represent by HCF of AB multiplied by their LCM, which I'm going to represent by LCM of AB. Now mind you, this is true only for two numbers. This is not going to be true. This result is not going to be true for three numbers. So please don't try and do A into B into C equals their HCF and LCM. This is not going to be true. this works only for exactly two numbers, right? Now, this actually brings us to a couple of very interesting conclusions, right? So let me draw these. I'll explain these conclusions through two cases. Now, let me take the first case. In the first case, let me take A and B as co-primes. So when the two numbers whose HCF and LCM must be found, they are co-primes. Now, another way of expressing co-primes is that A and B have no factors in common except one, which means that the HCF of A and B is 1, right? So I'll take an example. Let's take 15 and 16, right? So for these numbers, their HCF is 1, right? Now if I use this A into B equals their HCF into LCM, then 15 into 16 should be equal to their HCF multiplied by their LCM. Now since this is 1, the LCM of 15 and 16 is going to be equal to their product, right? So it's very straightforward to conclude that if there are two numbers whose LCM must be found and their HCF is 1, just go ahead and straight away multiply those numbers, because that's what their LCM is going to be. Okay? Now case 2. The second interesting case is that one of the numbers is a factor of the other, right? So if A is a factor of B, then let's see what happens. Let's take an example straight away. Let's take the example of 15 and 45. Now 15 is 3 times 5, so I prime factorize 15, and 45 is 3 squared times 5, 9 5 the 45, right? So the HCF is going to be smaller and smaller, right? So both 3 and 5 would be there present in the HCF, and I'll give it the smaller powers, so 1 and 1. And their LCM is going to be again 3 times 5, but I'll give them the highest powers. Now in this case, the highest power is again 1. So the HCF is 15 and the LCM is 45. Now, isn't this interesting to see that in case 15 is a factor of 45 and I have to find their HCF, then the HCF is the smaller of the two numbers, right? And the LCM is the larger of the two numbers, right? So that's because if A times B, if the HCF is equal to A, then obviously the LCM is going to be equal to B. So the second result is if A is a factor of B, then HCF is A, the smaller number, and their LCM is B, the larger of the two numbers.